AQ100 relays. This is a medium voltage product, and then we have also low voltage products. Looking very similar, the main differences are that there are some special schemes for the low voltage and special schemes for the medium voltage, and some working philosophies may differ. But we have on the top left, I'll just have a look if I can. Here, top left, we have this AQ110P, which is current and light point sensor unit. And then we have a 110F current and fiber sensor unit. The difference is actually how it's written here, that the point sensor and fiber sensor. Fiber sensor is more often used with the low voltage, and the point sensor is more often used with the medium voltage products, but they can be mixed, of course. So this 110P is measuring current, and then we can have up to 12 light detectors and one fiber for that as a combination. As a protection philosophy, 110F is identical. It is flush mounted like the 110P, and it has 3 light detecting fibers. Our point sensors and fibers are always supervised, fully supervised. So that's why our fiber is a loop, that if there is any cut, or if the fiber is broken, we can then have an input that something is wrong with the fiber, and it will be supervised, and the alarm will be sent. And same with the point sensors, that always point sensors also are fully supervised. Then we have point sensor units also flush mounted. Point sensor units 101, and then we have a similar protection philosophy 101D, which is DIN rail mounted. But the working philosophy is identical with these. So 12 light detectors can be installed with this 101D and also 101. Door mounted and DIN rail mounted. And then there is a special device which is called 101S. This is more for the more complex systems, for example, double bus bars and duplex switch gears. And we have some standardized schemes for these, that we can. This device has more binary inputs for these special schemes. 102 fiber sensor unit has 3 light detecting fibers. And all of these units has own power inside the device. So we could have, for example, one of the big units as a master, and then we can have several smaller units to the same protection system. And they do have a own power supply, so that is not the limiting factor. For the medium voltage, we have AQ2000, which is reusable arc quenching device, rated voltage up to 17.5 kilovolts. And can be tested. Mechanical lifetime or mechanical testing cycles can be up to 20. And actual quenching in real situation up to 2 times. But very good if we compare to any other products in the global level, that this testing is one of the very important thing that we can actually test these devices at the very end and do the full commissioning. Then our newest products based on the same medium voltage series, but like I told before, that we do have some special schemes here and special working philosophies. And from this page, I would like to tell more about this AQ1000. We will go through that better afternoon, but a very unique product in the world, also can be fully tested, and mechanical lifetime is 100 times, and that is if there is a testing, factory testing in every 5 years, this 100 times is definitely more than enough. AQ01 arc light sensor. We have 3 sensitivity levels, and this first one, this 8000 lux, is the we can say that it's the 99% of the all sensors delivered. So that has been fine-tuned to the spectrum level of the real arc many years back, and has been like that from the beginning. It has 3 wires, current-based information, 2 milliamps as a standby and 20 milliamps when active. 3 sensors can be connected in series, in line, up to 200 meters. So the rule is, thumb rule is that the last sensor maximum distance from the device is the 200 meters. Snap-in cable connector for quick installation, and shielded cable connection as well. Light and pressure sensor. This sensor type is sometimes or quite often used in the incomer cable section when there is no possibilities to measure current before, or the current is measured after the cable connection, which is very typical. So if there are no possibilities to measure current, this pressure can be the other factor of the logical AND gate, that we don't have current, but we have a pressure and light. So some people quite often ask when these sensors are used as a light only. Let's say that, for example, this one, which is quite often also used light only. We can select from all our devices that we can select sensors to operate and activate light only. And sometimes I get questions that can these sensors be activated from the sunlight, for example, and yes, in some case it is possible, and the current, typically the current has been the second from the logical AND gate, that there's in most common applications the current is there also to avoid nuisance tripping. There was one case actually. It happened. It was a sensor what was light only, and it was a cable end, and that cable end was there was like a window at the steel frame. There was a window that you can see inside the cable compartment, and then I got called that something happened. There was a nuisance trip, and then we investigated. There was also windows on that in that electrical room. There was also windows, and through those windows there was sunlight what came through the window, and then it goes through the cable end window also. And it was a very good luck that feeder was not important. It was like a backup feeder. So they were just happy that the sun is shining. So it was quite good luck in that sense. But quite typically, current and light are both at the same time. And then we have a different type of fibers. We have a plastic fiber and then glass fiber, and then higher temperature fibers. So these type of fibers can be used quite often in, for example, if the busbar section is fully open, these fibers are very easy to run through the busbar sections if they are not segregated. Or sometimes used with low voltage. Quite often, actually, that there are only fiber. Many times, low voltage has. If we are talking about just like a main breaker, one incomer and then feeders, then it doesn't really matter that you have many point sensors. It is just enough to have one fiber to go through all the feeders and busbar, and then there is only easy trip to the one breaker, which is the main breaker, incomer breaker. Sometimes fibers are used, for example, hydro plants. There are big generators, and around the generator stators, that there are some sparkings during at least the very old generators and stators. If there are sparkings, there can be it can be supervised with this kind of fiber. And can touch the live parts, so plastic or glass, it doesn't conduct any electricity, so it is also very good thing.
Mikko?
Yes.
Do we have examples of this loop sensor installation to a switchgear, pictures or something? We have a question in the chat about it.
Yeah, I can send later. I don't have in this PowerPoint. I don't have. But I can send later. I have something from my own, so I can. I have to have a look and search for
yes,
my own computer.
Collect it to the material we give after the training.
Yes, sure.
Yeah. Good.
Okay, thanks. All right. Okay, this current sensing technology, it's very unique. This is actually very easy to set up. I was just doing every now and then I want to also visit site and see how this product is actually working on site. And I was just doing one commissioning, and I was very proud that how easy this is to set up. For example, this set button, what we have here in each device, just pushing 3-4 seconds, and it will run the installation for the full system. And then just a quick push, it will reset. So it was very easy to approach product, and for example, pushing the set button 3 times, quick pushing 3 times, it will tell that what is connected, how many sensors is connected, or what sensor channels are connected, what binary inputs are connected, and so on. We do have a 4 trip output in each unit, and product like Robert mentioned also that arc protection is the target has been and the approach has been that as simple as possible, easy to commissioning, and that just enough functionality. Every module has isolated power module. We have a small power module and a big power module. And the smaller power module is mainly to the DC power, 24 volts to 72 volts, and then the big power supply from 80 volts to 265 AC DC. Optionally, one fiber sensor, also this 110P device. And we can measure 3 current inputs, 1 amp or 5 amp, and that we can select from the dip switches. We can also measure earth fault current. I don't know that many cases where this earth fault current has been in used, so mainly this has been built with 3 current inputs only. But it is available. And the power supplies, high-speed outputs, and lockout relay as an option. So a trip output 3 is a lockout relay. And then every unit has this self-supervision alarm. (101) and 101D, 4 arc sensor inputs. So altogether 12 sensors, 2 binary inputs. Thresholds can be selected from 24, 110, and 220. And this can be selected, or this has to be selected when ordering the device, because it is a hardware change. Some application examples, for example, with every unit, there is a possibility to make a standalone solution. If current is not necessary, then, for example, here is the light-only wind turbine solution, wind turbine application. So in this case, the settings would be very easy. There is a 1 fiber, and then there is 9 sensors in 3 channels, and 4 trip output. And doing the commissioning for such thing, it would not take that long time. Correct dip switch settings, and then push the button for 3-4 seconds, and then it's done. Okay, this is very similar than this is only with the fiber unit. So here we have 3 channels for the fiber, and maximum length is 40 meters, and then there is the one special fiber which is 50 meters. But for example, for the low voltage port, low voltage switch port, it is very if we have let's say that we have 3 fiber sensors which are 40 meters each, then it is more than enough for the one easy low voltage port. There is also here one example of the fiber loop application, that one of the loop sensor 3 is here within the bus bar, one of the sensor loop is with the breakers, and one of the sensor loop is with the cable ends. But if it's still if it's a low voltage board, quite often it is enough to have just only one fiber. And this unit is 110F here. It's measuring the overcurrent here, and it is sending the overcurrent information to the 102 unit here. And when 102 unit is sensing the light, it will then do the trips to these ones, all the feeders. This is one example of the low voltage when we have this quenching unit. We have this is a so-called main tie main application, that we have left side incomer breaker here, and we have right side incomer breaker here, and we have a tie breaker here. So it's called main tie main. And with this low voltage application, we are sharing the light information between two master units. And this quenching unit is very near the incomer breaker. So if something happens on the right hand side, these units can trip the tie breaker and then open the tie breaker and the main incomer breaker, and then this quenching unit will close. And the closing time of the quenching unit, it's 4 milliseconds. So 2 milliseconds for this device and 2 milliseconds for this master unit. And then very similar to incomer with tie breaker application for the medium voltage. And I don't know, medium voltage is a term which is not used in all the countries, and probably there is only line that there is a low voltage and high voltage. But in Finland and some parts of Europe, medium voltage is the term when you go over 1000 volts and you are less than 45 kilovolts. But medium voltage or high voltage, how do you like it to have? But mostly medium voltage boards are built with the point sensors. That is the most typical application. It's one sensor for each closed compartment. So for example, if we have a cable compartment, circuit breaker compartment, and a segregated busbar compartment, then we need to have one sensor in each. And if the busbar compartment is open, then we need to have one sensor in every 3 meters. Because the flash will travel very fast to the way of the energy. So in this case, we are sharing the current between the units. So it doesn't matter, is it the incomer left side or incomer right side? Both of these units are measuring current. And this is so-called light selective system. That if we have current here, the tie breaker is closed, and we have flash over here, we will still, because the current is shared between left and right, we will get the current from left side. Flash will be seen on the right side, and this master unit will know what to do, and it will open the tie breaker here and the incomer breaker here. And then if we have a feeder cable fault, we will measure the feeder cable. We will get the light signal from feeder cable. This unit will then open only on feeder. And typical LV application is the quenching device very close to the breaker, incomer breaker, and then this is done with the point sensors, and point sensors are typically for the bus bar, and low voltage it's quite often open, no segregation and no compartments between bus bar sections. So few sensors for the bus bar, and then for the feeder breakers and cable ends. And this is a quite typical application. There is a quite nice video in YouTube which tells very well this AQ1000 operation, and we can send the link, or you can try to find it from YouTube. That have a look Arcteq channel, and then find this AQ1000. It is very good description of the functionality. This quenching 4 millisecond quenching is quite new topic. There has been quenching devices probably 15 years, but at the moment there are no such device which can be tested. Most of the quenching devices are working with the pyrotechnics, and there is a kind of explosion inside, or there can be a strong spring. That the spring is also one-time use, or similar. That they are working like a car airbag. That when you have the fault, it will close one time, and then you have to change it. But it is good. But this is the only one which can be tested, fully tested. You can recharge it, test the device 100 times. Of course, very important is to have the commissioning mode. So in these terminals here, there is a commissioning input, and if you don't use that commissioning input, you can only use this device twice. So very important to know. So arc flash protection without quenching, still active very fast. It's around 7-8 milliseconds tripping time, and then the breaker delay, and then this AQ1000 will activate in 4 milliseconds. Will quench in 4 milliseconds. And this is just a similar curves, but idea is to activate at a very short time to eliminate the pressure and eliminate the damages for the board and for the personnel.
Mikko.
Yes.
Mike wanted to point out that do not leave the commissioning input activated more than 24 hours, because it will put the quenching device to disabled mode.
Very good point. Yes, this is important. So there are some details, and this is during the commissioning switch has to be on, but the commissioning switch should not be stayed over 24 hours. Thank you. And here are some values. So this device AQ1000 has been tested up to 100 kiloamps, and quite typical low voltage application is around 50 kiloamps. But there are more and more, actually low voltage boards are getting higher and higher values all the time, mainly because of the hybrid technology, but 50 kiloamps is quite standard, but there has been also already 100 kiloamps systems. But AQ1000 has been tested with 100 kiloamps. And the keyword is reusable. Full self-supervision. And IEC 6094791 highest class. And this highest class means that it is the only reusable, resettable. Then for this unit, we have a special monitoring software, which has a trip counter, temperature measurement, and event registers. We can see running hours. And for example, it is good to know the capacitor management function. So the capacitor, it is actually charged and recharged constantly. So there is a cycle that it is not good for the capacitor which is inside that it is always at the very stable level. And that's why we are recharging and charging it in a cycle. Then for the medium voltage AQ2000 arc quenching device. On the top right corner, there is a medium voltage switchboard, and there is a kind of a sample how this can be built and connected to the bus bars. So it is connected here on the side of the bus bars, and here you can see it from the other side. So it is connected with the copper to the existing bus bars. Idea is very similar than the low voltage ones. It is a 17.5 kilovolts, short circuit 50 kiloamps for half a second, electric life 2 operations and mechanical life 20 operations. For this unit, one good tip is that there are some micro switches here inside, and this device doesn't start charging before the micro switches are properly pulled out. So these when we do the recharging for this unit, this has to be pulled out. And very easily one of the micro switches is not connected, and then the loop is open. Like the micro switches are 3 switches here, and when the loop is open, it doesn't start. And here is some example how it's connected. So this AQ110 has the quenching output. It's the fiber output. It goes to the capacitor unit, which is fully supervised. And then there is, from the capacitor unit, there is a capacitor energy. So strong current from these wires, and then it is also connected with the Ethernet cable.
Nico, can I take one question from David? Does the AQ1000 store the trip time? Can you read the trip time with the Activate 1000?
That's a good question. I have to actually check that because I am not too sure.
Let's get back to that. No problem.
Yeah, I can get back to that.
Yeah.
Yeah, this AQ1000 software is for me it's a bit new. It has been there quite some time, but I'm I'm a bit studying myself for that, so I will get back to that. And then something from this. This is from IEEE committee. These calories and arc energy calculations. So this is one example that this IEEE 1584 gives the calorie values, and then it goes to the certain category, and that category will then tell what kind of overalls people have to wear. And with the arc quenching, these calories will be the most best category 1, or actually category 0 is not anymore existing, so it will go to category 1 then. And IEEE committee, they had this new standard 2018 for the new calculation methods, and they spent 16 years and they made 1200 explosions arc flash testings. So it is quite a lot of quite time consuming to do such testings. But yes, with arc flash relays we can already go to the good level, and with arc quenching to the best category level. So this is the ultimate solution, this arc quenching. All right, I will just open another one, and then yes, so I think I have some 20 minutes left, so I will open another one and then continue with you. Just a moment. And same thing, if you Roope can answer that, you can see this.
Yes, it's okay.
Okay, thanks. All right, product installation. So this is just some example of the flush mounted. That what is the cutout? It's very straightforward. Actually, easy to do the cutout and then just attach it to the door. There are several methods how to put the sensors. For example, here is one example with the bracket which has been riveted to the wall. One important thing is with the switchboard is that point sensor cabling, point sensor location should be in the way that, for example, the cabling is not next to any moving parts like for example, like medium voltage solder elements. That there are a lot of moving parts, and one important thing is that all the switchboard has some levels of insulation, that the point sensors should not be disturbing that insulation levels. So if there is at some point there is for example 20 centimeter minimum distance, we should not put the sensor closer to 20 centimeter. But that is just more like a common sense rules that the switchgear should have the same insulation level than before retrofit this arc flash protection. And point sensors can be mounted both ways. It can be mounted outside of the box or inside the box. I personally like myself more of the inside compartment installation. And of course, with the pressure sensor, you have to have always it inside the compartment, not outside. And the compartment for the pressure sensor has to be also quite tight. There should not be any air louvers or such openings. And the point sensor can easily see 1.5 meters inside the compartment. This is one example for the MV switchgear. So locations are, this is just an example drawing, but you can see that there is one sensor in the cable compartment. Sometimes these cable compartments may have a segregated wall, for example, for the voltage transformer. And if there is a voltage transformer, then that needs also own sensor. And so one sensor for the cable compartment at the very best location. This is not the best location, but it is an example. One for the bus bar and one for the circuit breaker. And for the circuit breaker, it is best to have in the location which sees the connection parts at the best, and then keep the cable away from the solder moving elements or any withdrawable breaker moving elements. So that is quite important to keep in mind. Typical sensor placing for the low voltage. This is done with the point sensors. So this is very common way to do if we have a horizontal bus bars and vertical bus bars. That we have this master unit or the relay itself, it's here. And then we have a point sensors. This one is this is the cable compartment. And this point sensor is looking left to the vertical bus bars. This one is looking right to the vertical bars, and this one is looking to the bus bar section. This is quite typical low voltage board, but this is a drawing what I just made as an example of the MCC board. Then, of course, if we are talking about low voltage switchgear, there might be some differences. Switchgear may have one of these incomer breakers and similar size of breakers here and here and here, and a lot of these big breakers. And that may have a own demandings then. So looking at the vertical bars here and horizontal bar here, and then one more common way to do it is to send fiber and route the fiber starting from here. Just go through the full system, full low voltage board, and back to the relay. And some ideas that the sensors should be able to test easily, should be able to replace easily, should be easy to retrofit. And if there are a lot of transport splits, for example, if this is a 25-meter long, there will be a lot of transport splits, and then this would be also taken into the consideration. Also, sensors in the bus duct. Quite typically, there is a bus duct or cabling to the transformer, and in that case, normally the overcurrent is measured if the transformer is here. Normally, in that case, the current is measured from the transformer end, and then also the sensors can be, or the fiber can be mounted to the bus duct. Or another option is to measure the current from the board itself, and then have the pressure sensor in this cable end or the bus duct end. And typically also point sensor to the circuit breaker, and sometimes also to auxiliary transformer, which may be, for example, inside here. Some installation examples. It can be centralized. These units here can be centralized to one door, or it can be one in the panel, one in the cubicle, one in every door. So it depends mainly that what kind of the application and what are the site conditions that we can select then the best methods on each site. Yeah. There are some examples of the sensor cable. Arc sensor each enclosed compartment and every 3 meters in open areas. Sensor cable typically this size. Current connection 4 square millimeter, and sometimes it is very common also to use 2.5. But 4 square millimeters is very good for this. This is an example low voltage panel with the arc quencher, which is here at the very under the breaker. And this is the bus duct connection here at the top, and then there is a current transformers and the pressure sensor. And this is a very good example of that. The current transformers are here. If there's arc flash anywhere in the board, these current transformers will see the overcurrent. But what about if there's arc flash here before the CTs? Then we may not see any overcurrent here. And that's why in this example, there is a pressure sensor in this box. And that pressure and light sensor will take care of this part of the box. And then here's the master relay, and then there is a fiber. There is a fiber connected to here, and there is another fiber which is connected to the AQ1000 here. So if we have overcurrent here, we have arc flash anywhere in the board, this relay will immediately start opening this breaker. And same time, it will do the short circuit to the bus bars with this AQ1000 device. Okay, so this is an example of the installation, and you can see. This is one application. You can see the numbers here. There is a scheme 2A, scheme 1. So in each of these devices, we can select a scheme. It can be standard scheme, or it can be something unique design scheme. But typically, all of these basic boards can be done with the standard schemes. And this example have for the master units we have a scheme 2A, and for these smaller units we have a scheme 1. I will skip this one. I'm talking too much, time is running. This one, like I said, that this is a configuration example. Because we don't have that much time, I will just tell you that we have the current selections here. The current threshold will be set from here, and then we have two groups of DIP switches: switch 1, switch 2. And I just put here the settings for this example. Scheme 2A is the scheme from here. Scheme 2A, when we select from these DIP switches, we have a weight factor here. It's a binary coded, so it's like a 1, 2, 4, 8. So if we want to have a scheme 9, we will have 8 plus 1. But now we have a scheme 2A. We should have this one on, and then we should have this one on. Then we have 2A. So this is actually very simple and straightforward. When you know from the design that you have a special scheme, you have a scheme, for example, 4A or 4B, you can then just select here 4 and B. So this part is pretty easy. Then from the design, you can see that yes, we want to have light plus current to all of the outputs. Light plus current. So from these DIP switches, we can select S1, sensor 1. We can select light plus current, light plus current, light plus current, like this here. We can, from the design, we can find that the current threshold for this design is 3 times nominal. We can switch this potentiometer. We can switch this one or turn this one to 3. First, we can inject current 3 amps, for example. Yes, we can select that we have 1 amp CT. We can inject current 3 amps constant with Omicron or any other test kit. And then turning these potentiometers left and right and try to find the threshold level under, over, under, over, and fine tune it to the closest to the 3 times nominal. With the Arcteq relays, it is not that critical because this has nothing to do with selectivity of any other protection relays. So our selectivity comes from the light and from the light detector. Latch is on, no pressure. So from these switches, we can select latch is on, high-speed output, latch is on. Latch on means that the relay will keep the latches closed, trip outputs closed, as long as we reset from the relay. Pressure and light, we can select this off because we only use light in this case. Fiber loop or this AQD, we can have it fiber loop here. We don't have AQD here. Fast or CPFP. In our example, we have only fast. So let's select this one to the left. And because it's a fast, this doesn't actually matter. It can be set off here. And then currents 1 amp CTs from here. So this is quickly switch 1 and switch 2. First the scheme, then light plus current, 1 amp CT, fast activation, fiber loop, no pressure, and the latch is on. And all these should be founded from the designs, how the designer has made it. And same here, this is the subunit 101, settings scheme 1. Scheme 1, it's here. Fast, it is designed as a fast. Latch is on. Light plus current, light plus current. And then after these dip switches has been set, press 3 seconds for this 101. It will find out that how many sensors are connected, and then press 3 seconds from the 110, and it will talk to this unit, and they will find out that how many units are connected and are the cable okay. Yes, so it's here. Press button for 3 seconds.
I think we could soon break for the